The Ben Heck Show is brought to you by Element 14. Visit element14.com/TBHS to learn how a purchase of $100 or more can get you a free subscription to Make Magazine while supplies last.
In the year 2000, Ben Heckendorn built his first mod.
We can rebuild it. Smaller, better, portable.
Since then, he has continued his work, helping those in need with creative new projects. Got an idea you'd like to see built? Why not send it to the Ben Heck Show?
Hello and welcome back to the Ben Heck Show. In this episode, we're going old school Ben Heck and building a small portable game system. In 1992, Sega released an add-on for its Genesis console called the Sega CD. This allowed users to play games that were CD-ROM based and could contain much more graphic data and music than the cartridge-based games, which were, maxed out at about 4 megabytes at the time. Anyway, a lot of the games were FMV nonsense, like Choose Your Own Adventure stuff or Night Trap, which actually I was quite fond of because I'm a big fan of cheesy movies. But there were some diamonds in the rough as well, such as Japanese translations of Lunar the Silver Star and Snatcher. A few years later, Sega released a all-in-one combo system that combined the Sega Genesis and the CD-ROM system into one fairly small unit called the Sega CDX. So the Sega CDX will be our build today. I'll dig one up, take it apart, and try to make it portable. Let's have at it. I often get asked, where do you find these old game systems? And the answer is eBay, just like anyone else, basically. So you find one that's not too outrageous. I mean, $829, what is it, like 5 copies of Lunar the Silver Star? There's gotta be at least 1 copy of Lunar the Silver Star. Yep, there it is. Some of the RPGs for the Sega CD were actually pretty good. I mean, it wasn't all FMV crap games, although those have a special place in my heart too. Alright, we got one in the mail, Sega CDX. I've never actually seen one of these in person before. It's a lot smaller than I expected actually. It's got a Sega Genesis, the CD-ROM circuitry, and of course the CD-ROM drive as well. So it starts small, so we should be able to make it smaller, hopefully. One thing that's kind of cool about this is you could put in 2 AAs and actually use it as a portable CD player too. It's always good to test something before you rip it apart, especially with older used equipment like this. That way you know that it was broken before you broke it. So I've got this little 4-inch screen that I'm going to use. And they're meant to run off 12 volts, but you can actually run them off a lot of voltages, like I'm going to try 5 here. Oh man, all these great crappy Sega CD games to try. Which one should I test it with? Well, this one is a soundtrack by Thomas Dolby of She Blinded Me with Science fame. We don't have audio hooked up, but I think this is the one I'll use. Let's see what happens. System on. Yay! That boots pretty quick, actually. Wow, it's like an interactive movie, but with 6-bit color depth. Oh no, not digital pictures. We're in for a rocky ride. Got a bottom metal plate, and wow, look at that. Wow. That's some heavy duty shielding there. It's kind of hard to see, but this part right here is actually a separate circuit board. See this small line here? And it appears to be the power regulator, so we might be able to replace this board entirely, but we know what it does. Alright, finally pried it apart. Appears to be 2 basic halves. Right here you can see the 2 processors. The Sega had a 68K Motorola, and then the Sega CD-ROM also had one. So the Sega CD-ROM system has co-processors. So we see those here. So this is the brains of the unit. Then up here over here, this is probably going to be the CD drive assembly. I know it looks overly complicated, but remember we're talking about something from 1995 here. These are our 2 basic parts. Main motherboard, CD-ROM. So that's what we've got to work with. With the Sega CDX taken apart, the next step is to draw the parts into the computer. So I came up with a basic shape here, which represents a circle, which might be the CD, and the screen inside of it. Now it's important to notice that a lot of the times in LCDs, the screen or the visible pixel area is not centered inside the frame. As you can see here, it isn't. So you've actually got to center the visible pixel area to your object, not the whole screen module itself. See how that works there? Which means This part's going to be lopsided. See how there's more excess stuff over here than over here? Which also means you have to make your frame or casing bigger. You know, if the screen was symmetrical, you could probably make it that small, but we have to make it at least this big to enclose the edges of it. So that's a common problem that I come across. And then we also do a side view which shows us the depth. On the screen here we have all the basic parts for the Sega CDX drawn into the computer. We have a representation of the main motherboard which contains most of the processors. Most of the processors. The Sega CDX, it has a Motorola 68000 as the main CPU. It has a secondary Motorola 68000 for the CD-ROM CPU, and then of course it has a Z80 for the sound synthesis. So if you had the Sega Genesis plus the Sega CD-ROM plus the 32X add-on, you would have a total of 5 processors, getting into Atari Jaguar territory there. So we have our parts here arranged on the screen, which represents the main motherboard, the CD-ROM motherboard, and of course the CD itself. So we have that as a base reference. So what we start to do is we make a case around that. So we need to find the minimum basic area around this. So usually I use about a 1/16 of an inch as a reference point. So it'll give me a box about like that. So I can show you what I've done here. Kind of have to build it backwards. This represents the rear piece of the unit. As you can see, it comes apart in two pieces here. You might wonder why you do that. See how this is a separate piece? The reason for that is we need to route an indentation here, like kind of a well, to make sure the CD has enough room. But then this piece down here is going to have these two little tabs for the battery, and those are going to be on the inside. So if we're routing the well for the CD here, but then we have to route battery tabs here, obviously we can route both sides, but it's more difficult because you have to make a jig. So it's easier just to make it two separate pieces so you can route them just from one side each. And then we go down in our layers here and we have another layer. Now this layer, as you can see, it's separated, flanks the outside and gives us enough room for the CD-ROM's motherboard here. And then down here there's a large area for the battery we're going to use. We see another layer which is pretty much the same, and then it has these circles here. Now the purpose of that is the machine's going to go in and just drill a whole bunch of little holes so the unit has these nice retro grooves on it like most things did in the 80s and 90s for some reason. It's like, let's make our electronics collect as much dust as possible. So here's another layer. As you can see, there's some tabs here which will line up to the screw holes so we can mount the circuitry to this layer. And then the final layer is the case layer. And at this point, we're not looking at it from the back, we're looking at it from the front. Now it's important to make sure you're looking at things from the right angle when you're drawing them, because if you draw everything from the front view, you might end up making a piece backwards. It might be mirrored the wrong way. So here's our front view. We have our screen, which is non-symmetrical again, but since we're not putting it on top of the CD, we actually have a little bit more wiggle room with what to do. So we have our minimum size of the unit, which is 5.5 by 8 inches, and then we make this shape around it for the screen to go in, so it kind of looks like a design feature instead of a mistake. And then down here, we have plenty of room for the controls. We have our D-pad, mode, start, XYZ, A, B, C. And also, since we're working in primitive 2D, I have to do two different views of everything, at least two different views. So we also have a side view here where you see how all the components are going to stack in. And then down here, I don't know if it's very obvious, but you can see the battery, which is that thing right there. It fits up underneath, and here's the tabs we talked about. So on this piece, we have to route that way, and then this piece, we have to route that way. And once all the pieces are done, we have to break them out so they can be routed. And we do it in such a way to make it kind of efficient. We have all the pieces, basically everything. There's an acrylic piece, a 1/2 inch stuff, and then 1/4 inch stuff. And that's pretty much all there is to it. Now, these sidewalls, we broke these apart into pieces. And the reason we do that is so it takes less space to route. I mean, full size would look like that. But if we group them like that, we can save at least 33% of our material. When we redesign a part such as a CD-ROM assembly in the computer, it's very helpful to make a physical printout of it. And the reason for that is because any modern printer, when you print something at 100% actual size and it fits within a piece of paper, the drawing will line up to the actual size of the object, so you can set it on the paper and make sure that you've got it right. Controlling the charge and discharge rate of lithium-ion batteries in your build is critical. Battery controlling ICs are easy to use and inexpensive, so you can fit them into any circuit you need. Element 14 carries a huge selection of battery charging integrated circuits from all the top manufacturers. You can also get chargers for other types of batteries such as nickel metal and nickel cadmium, all at element 14. Board level components, like battery charging integrated circuits, are very important for most projects. However, don't be put off by the complexity. If you need help, you can go to the Element 14 website and learn from the community. Ask a question, get an answer, and find what you need. With the designs done, it's time to route out the parts to build the case. We're using a high-density PVC foam called Comatex. It's easy to route and fairly strong. It's also easy to modify later on if our designs aren't quite right. Next, we cut the tabs to pull the parts loose from the sheet. We need these tabs since we don't have a vacuum table to hold down the small parts. The faceplate is flat, with the insides routed out for parts. We've also routed our own game controls, which insert into the case. We then move on to the parts cut from half-inch plastic, such as the LCD frame. The CNC machine cleans out the insides to hold the LCD and drills holes for the speakers. The LCD requires more depth than the game controls, so we made it as a separate piece which snaps into the front of the unit. This allows us to keep as much of the unit as thin as possible and also makes things look more interesting. The half-inch thick sidewalls are nested together to save us material. We export the toolpath from Partworks and it's back to the CNC. After drilling the holes to make the dust-collecting grooves, the machine cuts out the perimeters so we can remove the parts. Nesting parts saves material and reduces waste. We then do a test to see if everything fits. Sidewalls down first, and then the front layer. Looks pretty good. Here come the 1/4-inch pieces for the CD-ROM area. Let's check to see how these fit on the back of the case. First we have layer 4, then layer 5, then a CD. Voila! Next we need to be sure the electronics fit inside. Looks good. Okay, that fits. I think we're ready to start wiring the power. Now it's time to put the circuits inside of this case. We're going to start with the button controls, and we'll also use this little circuit board to mount the power regulator. So I've made marks where I'm going to put the drill holes. So the next thing to do is to flip it around and look at it from the front. And we're going to use a magic marker, very precise I know, to mark off where to put the tack switches for all the buttons. Now I'm using some surface mount tack switches here. I chose surface mount because they were smaller. A lot of stuff it gets hard to find anymore in through hole, you know, where the holes go through. But that doesn't mean you should be afraid of surface mount. Most surface mount stuff you can still solder in by hand. So what I'm doing with these, for instance, is I'm just putting them on a standard perforated circuit board that I got from Radio Shack, and not reflowing them, so I'm just using a little bit of super glue to put them in place. Then I'll go back and put on some solder on the leads so they will connect to the circuit board using the copper pads. I am a surface mount robot. Beep. So now that we've got all the buttons in, it's time to wire up the voltage regulator. What we're going to do is we're going to take a 7-volt lithium-ion battery and step it up to the 12 volts required for the Sega CD-ROM. Let's hope it works. Okay, I wired the step-up regulator using this diagram I got off the Newark website. I printed the pin out on one side and the application circuit on the other to save the environment. So we've got this 7.9 volt camcorder battery, and we're going to hook it up to our circuit and see if we can get 12 volts out of it. So here's power input here. Okay, I don't know if you can see that on the multimeter, but we're getting 12 volts. So now let's see if it's enough to power the Sega CD-ROM. Here we go. Okay, I'm using a Sean Mullins CD in case something goes wrong. I don't want to ruin any CDs I care about. Yeah, here we go. The screen pops up. So you've stolen 5 volts to power the screen, and it's running the CD player application, but it appears to be working. The next thing we need to do is connect an original Genesis controller to the one that we built. Unfortunately, we're using the 6-button model, which complicates things. It's really much more complicated than the 3-button Genesis model. The circuitry to drive it is under a glop top resin, so we've got to amputate this part off the board so we can use it on our own unit. This must be removed carefully so we can still see where the traces are meant to go. The next step is to remove the controller cable from our hacked up board. We will add a header to this so it can be easily connected to the CDX's motherboard. We count out how many connections we'll need. 9 for the controller, 1 for video, 2 for audio, plus an extra ground and an extra 5 volts.
Next, we check the connections on the cable using a multimeter and swap the board over to our custom connector, one pin at a time. We have to make sure this is right because if it isn't, we'll get confused easily. The CD-ROM mechanism and driver board has been made into a single assembly by using screws and rubber washers on the 3 mounting points. The LCD track time display has been removed. As for the main motherboard, we've removed the cartridge slot, tilted the power supply up, and rotated several electrolytic capacitors sideways to give us more room. The game system components mount onto 4 screw posts on the back of the unit, and a power switch goes to the top. Along with game controls, video and audio are added to the header that connects the sides together. Our camcorder battery clips onto the bottom via some Molex terminals that have been repurposed for this job. The battery then connects the step-up voltage regulator via another header. Again, it's important to build things you can take apart. Finally, it's time for the squish test, seeing if both halves fit together with everything inside. Aha! They do! I had no doubts.
TSA's never gonna go for this.
I've got the solution. You don't need all this.
Hey!
All you need is this portable Sega CD system. Oh, what's this?
That
Wow.
is one of the greatest games ever made, is what that is.
Yes, Snatcher.
Wow, look at this thing.
You could sell this on eBay for a great price.
I remember losing many hours to this game back in the day. Alright, so those of you unfamiliar with Snatcher, basically the game's Blade Runner, except it's cool. Wow, I've got plenty of space here for my extra knitting needles, cigarette lighters, and lithium-ion batteries. I think I'm all set for my trip.
Well, Jones, my work here is done. I shall take my fee and be out of here. Until next time. That's all the time we have for today. In our next episode, we'll be attempting a high-speed can cooler for when you absolutely, positively have to have a cold soda right now. We'll see you then. The Ben Heck Show is made possible by our sponsors at Element 14. For more information on all my projects and for a list of all the parts I used today, visit element14.com. We'll see you next time.